1 week later.
Morning, everybody. How are you all doing today?
Quite good. We are doing quite good.
Thanks for coming over. As you all know, I'm the new production manager here,
Yes.
and I need your help to understand the dynamics of this new place. To start with, I went through the efficiency monitoring system chart, and from what I can see, from this chart, I can figure out that the boiler efficiency is not up to the mark. It has been highlighted in red, and I think we should do something about it. How do we improve the boiler efficiency? And we should try to figure out the solution for it and make it more efficient. So I would expect some answers from the quality manager if you can give me some insights.
One week later.
Good morning, everybody. Good morning, boss. Yes.
Today we are using DMAIC methodology to improve the boiler efficiency in a coal-firing power plant. So boiler efficiency is of prime importance in manufacturing plants that generate steam for the purpose of productions. So we are using Six Sigma process DMAIC and to use it to investigate and further optimize the boiler efficiency in order to reduce energy costs and cut down on the coal consumption. Less coal burn, less carbon emission, less ash, and also giving a more cleaner living environment. In the first stage, we are in the define stage. So we define what is boiler efficiency first, which is the amount of the heat that transfer to heat up the steam per quantity of coal used. So you can see the flow diagram here. From the left hand side, we should the fuel, and from the bottom, we should be the FD fan taking the atmosphere air and combine it and burn it in the furnace where the combustion take place. So the flue gas, which is the products, will go through the air heater and also through the ID fan and emit in the chimney. So we got a few control parameter here, which ID fan controlling to maintain the furnace slightly negative, and also the FD fan to sustain the supply air pressure, and the feeder speed will be depends on the steam demand. So in the second phase, which is the measure, we are using the QFD diagram. We have listed what is the customer requirement, and on the roof there we can find out what is the technical requirement that we transfer to. For example, so second line, we minimal what is the excess air which doesn't take place in the reaction but being heated up and emit into atmosphere, which is a waste of energy. So we turn it into a technical requirement, mean that we want to reduce the excess O2 where the O2 is not taking place into the combustion. So we want to eliminate or reduce it. So we find out that from the QFD diagram, there is a few major factors that can probably impact the boiler efficiency, which is the flue gas temperature, excess O2 in the flue gas, and the emission CO. In the third phase, we are doing the analysis. We are using cause and effect diagram, and we can see that there's a lot of factors that contribute to the inefficient boiler, and some of the problems such as like inaccurate feedback affects the airflows, which is from the instrumentation fault, and also the dirty water tube surface that prevent the furnace to absorb heat. So these will be the sub-cause for maybe contributing to the inefficient boiler. So we use the mini lab to plot a Pareto chart, and we can see the main contributor will be the carbon at the excess O2 and also the flue gas temperature. So we mainly focus on these two parameters, and the rest will also be included into our control phase. So for excess O2, because it might be due to the inefficient or inaccurate instrumentation, so we propose to be sent for calibrations, or we propose to have a more accurate instrument for measuring the excess O2, so that we have a better control. For the flue gas temperature high, so we suspect it might be the dirty water tube that affect the heat transfer efficiency. So we suggest we do some install some instrument such as strip boring, that we use steam to clean the surface of the boiler water tube, so that it has a better absorption of heat. And also we will do inspection of the air heater, so that the air heat exchange will be optimized. The rest control will be focused on the CO emissions, carbon in ash, and also including some human factor, which also indicate the human may contribute to the inefficient boiler. So in conclusion, we are applying DMAIC methodology to find out how the excess O2 emission and also this factor to affect the boiler efficiency. And also we suggested some control method to reduce the excess O2 and also the flue gas temperature to optimize our effort of fuel. Thank you very much.
Thank you guys, it was a great presentation, and I'm sure the DMAIC methodology will benefit our organization. Great job once again. Thank you.